Let's talk about solving rational equations. The first step to solving rational equations is to factor all of the denominators. From there, we need to multiply both sides by the least common denominator of all of the terms. We can then solve the resulting equations. And finally, check our solutions. And this is going to be a very important last step, as we'll see as we go. Here's my first example, 1 over x plus 1 plus 1 over x minus 2 equal to x plus 3 over x plus 1 x minus 2. Here are my denominators already factored, so I can skip my first step. And I want to multiply by my least common denominator. On the bottom, I have an x plus 1 and an x minus 2, so that would be my least common denominator. So we can rewrite this, distributing out. I have 1 over x plus 1 times x plus 1 x minus 2 plus 1 over x minus 2 times x plus 1 x minus 2 is equal to x plus 3 over x plus 1 x minus 2 times x plus 1 x minus 2. Here the x plus 1's cancel, and I'm just left with x minus 2. Here the x minus 2's cancel, and I'm left with x plus 1. And here both of these things cancel, and I'm left with x plus 3. So we have the equation 2x minus 1 is equal to x plus 3. We can subtract x over to get x minus 1 is equal to 3, and then adding 1 to both sides gives me x equal to 4. So here's my solution. We do need to check, and really what we're checking is to make sure we never put 0 on the bottom of a fraction. So if x is equal to 4, I would have 1 over 5, which is fine, 1 over 2, which is fine, and then 7 over 5 times 2, which is fine. I never have 0 on the bottom, so this is a valid solution. My next example, 2 plus 5 over x minus 4 equal to x plus 1 over x minus 4. Once again, I don't need to factor here. And the only thing on the bottom of a fraction is an x minus 4. When I multiply, that gives me 2 times x minus 4 plus 5 over x minus 4 times x minus 4 equal to x plus 1 over x minus 4 times x minus 4. So here, the first term, I have 2x minus 8 once I distribute. Next, the x minus 4's cancel. I'm left with plus 5. And here, the x minus 4's cancel, and I have x plus 1. So 2x minus 3 is equal to x plus 1. We can subtract the x over. That gives me x minus 3 equal to plus 1. And adding 3 to both sides gives me x equal to 4. So sticking that back in and checking, I have 2 plus 5 over 0, which is bad. So this right here is actually not a solution. And this would have no solution since we can't have 0 on the bottom of a fraction. I now have x over x minus 5 plus 3 over x plus 2 equal to 7x over x squared minus 3x minus 10. So far I've got to skip the first step of factoring, but here I can't. I need to start by actually factoring this denominator on the right-hand side. Two numbers that multiply to be negative 10 and add to be negative 3 are going to be negative 5 and positive 2. From there, I can multiply everything by my least common denominator. We know there's an x minus 5 on the bottom and an x plus 2 on the bottom, and then that's the only terms that are on the bottom of fractions. So that means I have x over x minus 5 times x minus 5x plus 2 plus 3 over x plus 2 times x minus 5x plus 2 is equal to 7x over x minus 5, x plus 2, times x minus 5, x plus 2. Here the x minus 5's cancel. I'm left with x times x plus 2. Here the x plus 2's cancel. I'm left with 3 times x minus 5. And over here, the x minus 5's and the x plus 2's cancel, and I'm left with 7x. Distributing, we have x squared plus 2x plus 3x minus 15 equal to 7x. This means x squared plus 5x minus 15 is equal to 7x. We can subtract 7 from both sides to get x squared minus 2x minus 15 equal to 0. And then we need to factor. Two numbers that multiply to be negative 15 and add to be negative 2 would be negative 5 and positive 3. This gives me x minus 5 is equal to 0, or x plus 3 is equal to 0. So my solutions are 5 and negative 3. But once again, we need to double check. So if I go back up, a solution of 5 means my very first fraction becomes 5 over 0. So that's bad and not a solution. X equal to negative 3 would give me a negative 8 on the bottom and a negative 1 on the bottom. Here I would have negative 8 times negative 1, both of which are perfectly fine. So here I only have one solution, x equal to minus 3. Let's do one more. We need to start by factoring. The first two are already factored, so we don't have to worry about those. On the right-hand side, to multiply to be minus 3 and add to be minus 2 would be negative 3 and positive 1. And so now we can do our common denominator. There's an x plus 1 on the bottom and an x minus 3 on the bottom. We then distribute this 1 over x plus 1 times x plus 1, x minus 3, plus x over x minus 3, times x plus 1, x minus 3, equal to 4x over x plus 1, x minus 3, times x plus 1, x minus 3. Here my x plus 1's cancel. I'm just left with x minus 3. Here my x minus 3's cancel. I'm left with x times x plus 1. And here the x plus 1's and the x minus 3's cancel. And I'm left with 4x. We can then distribute. That gives me plus x squared plus x. The left-hand side is then x squared plus 2x minus 3 equal to 4x. And subtracting 4x gives me x squared minus 2x minus 3 equal to 0. We can factor x minus 3x plus 1. So now I know x minus 3 is 0, or x plus 1 is equal to 0. That tells me my solutions are 3 and negative 1. But like I said, we do need to double check these. Let's start with 3. If I go back to my problem, that would be 1 over 3, or 1 over 4, which is fine, and then 3 over 0, which is not fine, so this is not a solution. What about negative 1? Well, that would give me 1 over 0 in my first term, which is also not okay. So here we have no possible solution.